Hey everybody, this is Larry, this is me going with Cube 4 of the bi-weekly contest 122, divide an array into subarrays with minimum cost 2. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. So this one, I kind of talked about some observations in Q1, but this is obviously a very different problem. But I think the first thing that you should do, well, I mean, okay, so n is way bigger, right? And you have this k and distance thing, which I don't know what that means, right? But this is what you have to try to understand for this problem. And for me, to be honest, I had just woken up and I was not really ready to kind of like really understand this problem. This is a hard to read problem and very understandably. But okay, so for Q1, I'm going with Q1 just kind of as a let me actually bring it up real quick. Just to bring up Q1. So you can do this with this brute force way, but another way to think about it is that because you have this subarray, but there's nothing about that subarray. You just care about the first element of each of the quote-unquote subarray, right? And so as a result, for Q1, or you can also reduce this to a linear time solution by just saying that, okay, I need the two smallest elements that is not the first element, right? So that's basically the idea behind this one. And in that way, you can think about here, let's say we don't have this distance metric, right? Let's say we only have k, and we're trying to partition into k different subarrays, then it just becomes a problem of getting the k minus one smallest elements in the array. And if that's the case, you can sort and return the first k element or whatever, right? Of course, you have to include the first element. So it's the k minus one smallest element in after the first element, right? So that's basically how I would think about it without distance. So what does it mean with distance? So this distance is a very awkward thing. So distance just means that from the first element, let me actually move this to the thing. So the distance just means that, and we could discount the first element, but it means that for the first element of the quote-unquote subarray, the last one has to be within distance plus one away or something like this, right? Yeah, something like this. Give the distance, or it contains distance plus one element is what I mean to say. Is exactly distance away, right? Yeah. So then now, using the same phrasing that we had, then this is just becomes for so the way that I thought about it is that means that if we have a way to brute force the beginning element, say this is the first index, this is how do they call it? This is I sub 1, then now if this is I sub 1, then we consider the next 4 elements and then choose 2 of them in this case, right? That's basically the idea. And so from that, my idea was that just have a sliding window, right? One at a time, and have some way of doing a sliding window. And when we have a sliding window, what are we doing? We're trying to get the minimum k minus 1 element in a sliding window kind of way. So that's basically what this problem boils down to, and that becomes for me anyway, easier said than done, because initially I was going to break out the heap, because when you think about min elements, but then it actually, because of the sliding window part, you actually add and remove from the middle. And I think if you have a reasonable, actually no. So it turns out it not to be a heap problem, but as well, the way that I did is with sorted list, right? And with sorted list, and I think in other languages you can also use, like in C++, there's like order statistic tree or something, and you could probably do the same thing. But the idea here for me is just to keep track of, we're given a sorted list, it just becomes bookkeeping, because then now here, let's just say we have this array, right? Then the idea here is that we keep a sort of a heap, but really just it's a sorted list, right? We have a sorted list. So then now let's skip this one. right? First element, and then we have 3, and let's say we only care about 2 elements. Then now so the way that I did it is by bookkeeping keeping track of the first k elements in the sorted array, right? So now here, let's say the total is equal to 0. We added 3. The total is going to be 3. And let's say we want to just keep track of the first 2 elements, right? So then now, and then you added 2. The 2 is in the first 2 elements. So then we added, so this is 5. And then 6, right? So we added 6, but it is not in the first 2. So then, yeah. And then maybe you add a 4. So we added 4 here, still not the first 2. So we don't care about it. Right, and then now I'm going to add more random numbers just to but to illustrate it a little bit more. So now we added 2, right? So there are a couple of ways to do it. The way that I did it is by removing well, yeah. So basically the 2 operations, right? So because out of 4 elements, right? What did I drop? Anyway, yeah, so now we have these 4, but so there are 2 operations that you have to do for this sliding window, because you have this thing, you want to move it to this thing. So then you have 2 operations. One is adding the 2, and the other is removing the 3, right? And you can do this in either order, I think. You just have to be really careful and really off by ones. But let's say I add first, so then now it becomes 2, 3, 4, 6, right? So what this means is that now the first 2, because we added here, or maybe here, depending on how you want to say it, then now that means that you want to remove the 3 and add 2, right? So then now the total is going to be 4, which is 5 minus 3 plus 2, because 3 got pushed out. So then now you have a 2 thing, right? And then after that, you actually have to remove the 3, which actually is pretty straightforward. You have 2, 2, 4, 6, right? And then next you have a 5. We don't actually that's not true. Okay, so yeah, you remove another 2, right? So then you have a now we're trying to add 5 and remove 2. So here we add 5, so you have 2, 4, 5, 6, and it doesn't change the first 2 elements, so total is the same. And then we remove 2, which, so you remove the 2 and then you add the 6, right? Oh, sorry, you remove the 2. So this is going to be 5 minus 2 plus 4, right? Yeah. Did I mess up? Oh, it went. Oh no, this is not 5. This is 4. Whoops. But yeah. So then 4, you remove the 2 and then you add the 4, because now it is the 4. So basically that kind of idea, and it just becomes, like I said, tracking things and making sure that every state of the array is the same. And I'll show you my code, obviously. But yeah, so it's pretty straightforward in understanding. The coding is a little bit yucky, and I kind of, if you saw me, I have like all these print statements just to make sure that because I actually spent a good time debugging it as well. But yeah, but basically here, like I said, we want the smallest k minus 1 element of this, and then this is the removal part. Basically, this is just saying that if we split out of some other numbers window, then we have to remove it. And this is the previous index. We binary search for the number, see if it's in the beginning. If it is in the beginning, then we have to kind of we have to remove it and then add the next element that's outside, that was just outside, and then you remove it. Otherwise, I mean, in either case, we always insert. So this is the index gives you the insertion point. So then if this is within the index, then we add it to the sum. Yeah. And if we have enough elements, then we subtract the next element that we just pushed off. And the index is a little bit weird because this is before we added. I don't know if this is like the cleanest way to do it, but anyway, right? And then after every iteration, we just check to see if, or every iteration in which we have enough numbers, we just check to see if, yeah, it is better than the current best. And that's pretty much it. And of course, at the end, you have to add in the first element because that's just one of the subarrays. Yeah, so that's pretty much it. Basically, you want to, another way to say it is that given every subarray of distance plus one element, you want to choose the smallest k minus one. And it becomes, it is just like a sort of an frustration of the problem. But yeah, that's all I have for this one. This is going to be n log n. We have a sorted list. I guess it's actually n log k, maybe. Yeah, is it k or no? Well, it's n log distance actually, or d maybe. So n log d, because out of the d you want to keep the smallest k. Yeah. So yeah. So the sorted list will have at most d elements, and you do log d operations, maybe up to 4 of them, right? Or 4 or 5 or something like this. Maybe a couple more, like 6, right? Because this is 1. I think this is a log n operation. This is the log n operation, and you same. You have 6 or 3 more on the bottom, so 6. Either way, constant number of log n operations. So yeah, that's all I have for this one. Let me know what you think, and yeah, you can watch me solve it live during the contest next. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, this contest, everything in between. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye-bye.